Right there, yeah.
What is your view on panspermia or exogenesis?
Panspermia is the notion that life on Earth didn't originate on Earth, but came here from some other place. I find this to be an intriguing notion. I would argue, and I think most biologists would say, that the capacity for life is built into matter. In other words, the very laws of physics and chemistry give what we call inanimate matter, carbon, oxygen, nitrogen, hydrogen, the capacity to become alive when arranged in a certain way. I would be astonished, given the vastness of the universe and the constancy of the laws of physics and chemistry, if this little planet zipping around a medium-sized star in a nondescript galaxy was the only place in the universe where that had ever happened. So I'd be very much surprised if life is only confined to this one planet. Do I think life might have come to this planet from somewhere else? It's possible. Meteorites fall into Earth all the time that have organic compounds on them, complex chemicals. Now, how did they originate? We think they originated by the same natural processes that primitive organic chemicals originated on this planet. So that means elsewhere, even in our own solar system, the building blocks of life might be in the process of assembly. I don't think, however, saying that life on Earth arose by panspermia solves the scientific problem of how did life originate. It would just put it on another planet. One way or another, ultimately, a great scientific challenge is going to be to figure out where life came from. Panspermia doesn't get us any close to that, but I think it's an attractive idea given the vastness of the universe and the capacity of matter for life. Right up front. That'd be you.
Do you think there will continue to be breakthroughs in evolution in the future?
It's a good question. Will there be breakthroughs in the evolution in the future? There are breakthroughs in evolution literally every time I open a scientific journal. I see one or another of them. There was a paper about 3 weeks ago that was published in one of the world's leading journals talking about speciation mechanisms, the genetic mechanisms that take a single species and divide it into two and prevent the newly separated species from interbreeding with each other. That's really the first step to forming two species. And what these studies showed is that a very simple single mutation, this was in Drosophila, the fruit fly that we use for lots of laboratory studies, but a single mutation could separate two species so they could no longer interbreed. That was remarkable because prior to that, people thought, as I showed in one of my slides, that this might take years or even decades. We now know that in certain cases it can happen in a single generation. So yes, I think there will continue to be breakthroughs. We continue to find new fossils. A spectacular new fossil was found in Africa just last week, or reported just last week. And finally, evolution is the tool that we use to investigate our genome. In other words, the exploration of the human genome, the DNA sequences that make us human, that exploration wouldn't be possible without using evolution as a tool to compare ourselves to closely related and distantly related organisms to see where natural selection has happened on us. And every time we do that, we find new things out. So I'm confident that new breakthroughs are going to continue to happen. I should have brought a bag with a whole bunch of these. Sir, right in the center, blue shirt, yeah.
So because of these mutations, people change. So do we have actually a method of predicting as to when these possible mutations will take place?
Well, one of the fun things, if you want to call about mutation and genetic change, is that it is to an extent unpredictable. In other words, you simply don't know where errors or mistakes or duplications or translocations of DNA are going to pop up. So in that sense, we don't really know. However, Sean Carroll, one of the people who gave the earlier lectures in the evolution series, pointed out that we animals actually have a genetic makeup that builds the body. In other words, that produces top, bottom, belly, back, head, tail, limbs, segments within our body, which we can actually see in blocks of muscle and blocks of bone and so forth. And the genetic makeup that produces that body, he argues, is actually almost predisposed to produce useful variation. So even though we don't know where the genetic change is going to pop up, the genetic makeup of organisms around today is actually geared to accept that and to produce useful variation. Now, one of the things that evolution does, and this is a technical term, is it explores adaptive space. Now, what that means in a jargon sense is that organisms basically reach out in one direction or another, and it's natural selection that fine-tunes that variation and finds the solution. So if we start to use new antibiotics in our hospital, we can be certain that the bacteria we're trying to kill are going to evolve resistance to those antibiotics. We don't know where the mutations will come from. We don't know when, but we can be certain, because we're creating a form of natural selection, that that can happen. And we see this kind of change all the time. So to that extent, it's somewhat predictable. Okay?